Hi, hello friends, welcome to our channel Study of Mathematics.
Next, we will go to the next problem in the exercise 3D section 2. The problem is problem number 6. The problem is if delta 1 equal to a1 square plus b1 plus c1, a1 a2 plus b2 plus c2, a1 a3 plus b3 plus c3, and second row is b1 b2 plus c1, b2 square plus c2, b2 b3 plus c3, and the third row is C3 C1, C3 C2 and C3 square, and the delta 2 value delta 2 equal to determinant A1 B1 C1 A2 B2 C2 A3 B3 C3. Then find the value of delta 1 by delta 2. This is our given problem. In this problem we have to given one delta 1 determinant value, delta 2 determinant value. Then we have to find delta 1 by delta 2 value. For this finding we have used delta 1 can be simplify this determinant. Very lengthy determinant can be split into small determinant. Then next we will find out the delta 1 by delta 2 value. Then for that solution is that given that take delta 1 value, delta 1 equal to determinant a1 square plus b1 plus c1, a1 a2 plus b2 plus c2, and a1 a3 plus b3 plus c3, and second row is b1 b2 plus c1, c3 c1, b2 square plus c2, b2 b3 plus c3, c3 c2 and c3 square. This is our delta 1 value. By keen observation we have to simplify this delta 1 by using some operations and some common terms by taking other side of the determinant, and given delta 2 value is, and given delta 2 equal to determinant a1 b1 c1, a2 b2 c2 and a3 b3 c3. This is the written determinant value. Now we have to take delta 1 value. Then now delta 1 equal to determinant a1 square plus b1 plus c1, a1 a2 plus b2 plus c2, a1 a3 plus b3 plus c3, and second row is b1 b2 plus c1, b2 square plus c2 and b2 b3 plus c3. Third row is c3 c1, c3 c2, c3 square. By keen observation of delta 1 value, in the third row we have the common term is c3. We have to take it other side of the determinant. Then c3 will get common, c3 into a1 square plus b1 plus c1, a1 a2 plus b2 plus c2, a1 a3 plus b3 plus c3, and here b1 b2 plus c1, b2 square plus c2, b2 b3 plus c3. Here taking c3 as common, then first term remaining term is c1, here c2, here c3. This is the determinant value. By subtracting R2 and R3, one of the operation is that R2 is going to be, and first R1 is also, R1 is going to be R1 minus R3, and also R2 is going to be R2 minus R3. Then that is equal to C3 into determinant R1 minus R3. R1 value is A1 square plus B1 plus C1 minus R3 minus C1 plus C1 minus C1 get cancelled. The remaining term is A1 square plus B1. Here A1 A2 plus B2, A1 A3 plus B3, because A1 A2 plus B2 plus C2 minus C2 plus C2 minus C2 get cancelled. Here also A1 A3 plus B3 plus C3 minus C3 plus C3 minus C3 get cancelled. Then remaining values A1 A3 plus B3. In second row also same the operation R2 minus R3. That means B1 B2 plus C1 minus C1. The remaining term is B1 B2. Here B2 square, B2 B3. Here C1 C2 C3. In next step, that is equal to C3 into. In second row, we have the common term is B2. Take it the other side, B2. Determinant. The first row is A1 square plus B1, A1 A2 plus B2, A1 A3 plus B3. Second row, B2 get common, then B1, B2, B3. The third row is C1, C2, C3. This is the determinant. Here also we have to apply one of the operation is that R1 is going to be R1 minus R2. R1 is going to be R1 minus R2. That is equal to C3 B2 means B2 C3. Determinant R1 minus R2. R1 is A1 square plus B1 minus R2 means minus B1 plus B1 minus B1 get cancelled. Then A1 square. Here A1 A2, A1 A3, B1 B2 B3, C1 C2 C3. That is equal to, here first row we have to take common A1, then A1 B2 C3 into determinant A1 A2 A3 B1 B2 B3 and C1 C2 C3. This is the delta 1 value. Delta 1 value is A1 B2 C3 into determinant of A1 A2 A3 B1 B2 B3 C1 C2 C3. Then next, already we know one of the property of a determinant is that determinant A is equal to determinant A transpose. The matrix A determinant value is equal to that matrix transpose of a determinant is also equal. By using that property, we have to A1 B2 C3 into determinant. This can be turn it into A1 B1 C1 A2 B2 C2 A3 B3 C3. The rows and columns are interchanged. By using this property, determinant of A is equal to determinant of A transpose. By using that, we have equal values. Then this delta 1 value is equal to A1 B2 C3, determinant A1 B1 C1 A2 B2 C2 A3 B3 C3. That is equal to delta 1 is equal to A1 B2 C3 into this determinant value is equal to delta 2 from the hypothesis. From hypothesis ante problem. From the problem statement, we have that delta 2 value is determinant A1 B1 C1 A2 B2 C2 A3 B3 C3. Then from this, now this is the delta 1 value. Now we can calculate the delta 1 by delta 2 value. We have delta 1 value is A1 B2 C3 into delta 2. divided by delta 2. Here delta 2 get cancelled, that is equal to a1 b2 c3. Therefore, delta 1 by delta 2 value is a1 b2 c3. By using, this can be solved by using the given hypothesis. First, we can take the delta 1 value by simplifying that determinant into this by applying some operations and some taking common terms. Then we have the delta 1 value is delta 1 equal to a1 b2 c3, determinant a1 a2 a3 b1 b2 b3 c1 c2 c3. Here we apply the one of the property of a determinant is that determinant of a matrix is equal to determinant of that matrix transpose. The determinant of a matrix is equal to the determinant of a that same matrix transpose. By using that property, we have convert this determinant value into the transpose of a determinant, that is determinant a1 b1 c1 a2 b2 c2 a3 b3 c3. Then this value is nothing but delta 2 taking from the hypothesis, that is delta 1 equal to a1 b2 c3 delta 2. Now we have to find out the delta 1 by delta 2 value, that is equal to delta 1 value is a1 b2 c3 into delta 2 divided by delta 2. Delta 2 get cancelled, then that is equal to delta 1 by delta 2 value is a1 b2 c3. This is the solution of the sixth problem in the section 2. Thanks for watching.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.